Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ARP, Performance Plus Global Logistics, Scott Lewis and Associates today, and PIC, Shock Monkey, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of EPARTRADE, the global platform for the performance and racing industry. This is episode 350, and we're going to be talking engine bearings technology with Dido and Roush Yates Engines. Now, this is a very special episode, and I will tell you why. Number one, it's episode 350. So if you had told us 3 years ago in June 2020, when we produced our first ever episode with John Causey and Lake Speed, that 3 years later, it will be episode 350 combined between Race Industry Now and Race Industry Week, I don't think we would have ever believed that. So I want to say a special thank you to our wonderful hosts, Brad Gilly and Jeff Hammond, because they play a tremendous part in the success of this series. I want to thank each and every one of you out there watching us and who have been watching every single episode. And I want to thank the industry who believed in this platform and believe in all the content we produce. So thank you, thank you, thank you from each and every one here at EPARTRADE. The second point I wanted to make is Dido is a terrific company I've worked with for probably 15 or 20 years back to my PRI days. And I pushed Dustin to come on the series for a long, long time. And he's finally coming on and he's bringing some very special guests. So I'm very excited. With me this morning are Judy Kin, the co-founder of EPARTRADE, and of course, our wonderful host, Mr. Brad Gilly. Judy?
Thank you, Francisque. And you know, Brad and Jeff make us look good. So thank you, Brad. So it's an honor to have two prestigious and acclaimed companies on with us today. Thank you. And, you know, just the racing lore of Roush Yates going back to Robert back in the day. I've known Robert and now it's continuing with Doug Yates. What a team they have there. And I don't know of any other race team out there that treats their sponsors any better. So it's an honor to have two great racing businesses with us today. Brad?
Yeah, it definitely is. And thank you both for the kind words. And I know I can speak for my counterpart, Jeff Hammond, when I say we appreciate, number one, being a part of this, but probably more importantly is we appreciate what EPARTRADE does for the racing industry as a whole, and an amazing resource, not just with the webinars that we do every week, but also Race Industry Week, which is going to be coming up right around the corner, and just the website itself, an amazing resource to find parts, suppliers, and all of that. So thank you for creating this.
I think our guests are on, so let's dive in.
All right, that sounds great. Well, today's topic, engine bearings technology, a case study with Roush Yates Engines by Dido. And as always, if you have a question at any time throughout the webinar, just please feel free to type it into the chat, and we'll get as many of your questions answered as we possibly can. Again, this is just like a trade show. If you were standing there and you had curiosities about what we're talking about, feel free to step in and ask the question. But our panelists today are Dustin Cole, Account Manager, Racing and Aftermarket with Dido, Tom Yukai, Chief Engineer, Dido, and Mark Meagle, Manager, Design and Analysis, Roush Yates Engines. So, gentlemen, welcome. And I just want to go one by one and introduce you to everyone who's viewing here today. And Dustin, let's start with you. Tell us a little bit about yourself and about what we're going to be talking about today.
Hi, thanks, Brad. My name's Dustin Cole. I've been with Dido for about 7 years, a little over 7 years. I got brought into the company specifically to head up all of the racing and aftermarket business in North America. You know, to tell you that Dido's primarily been an OE supplier for you know, the majority of its life. So to see the support that we've got and to be able to take the technology that Dido has and bring it into the racing market has been a really unique experience for me, and it's been very exciting for all of us. So
awesome. Well, Tom, let's go to you next. Tell us about what you do at Dido.
Yep. I'm Tom Guy, Chief Engineer of Dido USA. I joined Dido since 2005. And we've been working with Roush Yates since 2011, 2012. and we are happy to work together with Roush Yates.
Awesome. Well, speaking of Roush Yates, we're also happy to have Mark Meagle here with us today. And Mark, tell us a little bit about what you do with Roush Yates Engines.
All right. Yeah. So my name's Mark Meagle. I've been with Roush Yates for about 2 years now. I'm the manager of our design and analysis group. And in that role, I basically have responsibility for the design, manufacturing, quality, and durability of all the parts in every engine that we send to the track or to a customer. Prior to this, like Dustin, I've spent a lot of time in the OE world, as well as a little bit of high performance applications on the side. Been doing powertrain design and development for about 30 years now. So.
Wow, that's impressive. Well, we're going to be talking about engine bearing technology and obviously working for an engine builder. Mark, we're just going to go ahead and start with you and give us an idea about the engine platforms that Roush Yates Engines designs, develops, and builds.
All right, so probably the thing we're most well known for in my background there, you can see the FR9 platform, which is used by, of course, all the Ford performance teams in the NASCAR, Xfinity, and Cup Series, as well as some other racing series that we supply that to. We have a couple other engine platforms as well. The RY45, which is a Roush Yates designed and developed aluminum block V8, really purpose-built for off-road high-performance applications. You might somewhat think of it as an aluminum blocked FR9 with a lot more displacement capability. We also produce the GT4 Mustang engine that is currently raced in IMSA, Michelin, Pilot, and VP Sports Car Challenge Series, as well as the 3.5 V6 EcoBoost platform that was previously raced in IMSA DP and GTLM and won Le Mans, and is currently the production engine for the last run of the Ford GT, the Mark IV track day only vehicle.
Wow, that's really cool. It's pretty amazing what happens in that building and really how worldwide it is for sure. So, well, we're talking about engine bearings, Mark, and let's talk about the relationship that Roush Yates Engines has with Dido. How long have you guys been using them, and maybe give us a little bit of background of how they help you?
Yeah, so as Tom mentioned, we've been working with Dido since 2012. They're one of our extremely valuable supplier partners. And that close relationship has allowed us to be very successful with the FR9 platform in the NASCAR series, as well as recently we've started looking to expand the usage of those bearings into our RY45 and the 3.5 liter EcoBoost platforms.
That's really cool. All right. Well, Tom and Dustin, want to chat with you guys, and I know you have some slideshow stuff to show us as well. But when you and I were talking yesterday, Dustin, one of the things you mentioned, bearing design has kind of been the same for about 60 years or so. And I've always thought of engine bearings as, well, they're designed to work, but obviously there are more performance applications and being able to get a lot more out of them as well. So give us a little bit of an overview, and either Tom or Dustin, whoever this is better directed to, as far as bearing technology and everything.
Yeah, Tom, do you want to go ahead and share the slideshow?
Yep. Okay. Let me share.
There we go. All right. So what are we looking at here, gentlemen?
So, bearing technology. So, bearing, especially for performance engine bearing, it's 3 layers, like half shell parts, and top layer will be like overlay. Typically, performance after race parts will be ready overlay. Underneath of ready overlay, it will be copper based alloy. So copper based alloy itself has high load capacity, but it doesn't have good like conformability. Therefore, we have like really soft material on the top, and third layer, bottom layer will be back steel. And Daido metal itself, we have we make like bimetal, we call bimetal. We bond together steel and copper alloy, and we also machine the parts, and like especially for racing performance after parts, it is required like high like tighter tolerance. So we make like good quality parts, and we also have analysis technology, like using CAE and other measurement tools.
Yeah, one of the things that you mentioned, Brad, during our conversation yesterday, and something that I actually find pretty interesting about, you know, just from my experience of applying bearings in the racing world, you know, in most cases, technology tends to go from the top down. In the bearing world, you know, because we're such a large OE supplier, and the increasing demand for emissions and fuel economy and all of that, Dido is a bearing supplier. We've had to, you know, develop new materials, polymers, manufacturing techniques, and all those things, which we're actually finding, you know, to achieve that better economy, you know, those processes translate very, very well into the racing market. And that includes both leaded and non-leaded materials, especially in a lot of the European markets where everything needs to be RoHS compliant, all the way up to, you know, the supercar market. You've got, you know, a lot of these engine or, you know, vehicle manufacturers that are producing, you know, multi-million-dollar hypercars that are producing upwards of 1,000 horsepower or more, but because their production vehicles still need to be RoHS compliant or lead free, those are things where we really excel by you know, developing materials that work well for those types of programs. And then all of that, you know, longevity, all the durability testing and things that the OEs perform, you know, we can you know, really see that translation into the racing and aftermarket.
Yeah, that's interesting. And looking at the core technology with the bimetal and the surface treatment and all of that, how about the construction and maybe some other things that, you know, definitely set you guys apart with what you're doing at Dido on the performance side of things?
Yeah, I mean, as far as the construction of the bearings really haven't changed much. It's very small processing technology that has allowed us to excel, I think. In the precision processing technology little bullet point there, you can see that you know, a lot of our products we machine and control the wall thickness tolerance down to a range of 3 microns, which is incredibly small tolerance. You know, we're getting into almost the aerospace type machining tolerances, and those are really the types of things that engine builders and vehicle manufacturers have learned for that extra edge of competitiveness, power, and durability, fitting those oil clearances, having that very tight wall thickness tolerance makes a huge difference. So, and because we're such a large supplier, that's built into our DNA. Really, that's kind of our bread and butter.
Yeah, that's interesting. Tom, did you have another slide that you wanted to show us as well?
Yes. So bearing structure wise, typically like three types of bearing. First is single layer structure, and second is double layer we call bimetal bond together with steel, aluminum, or copper alloy, and third one is triple layer structure. We have like copper based bimetal with overlay, leaded and non-leaded overlay. We also have like aluminum based bimetal with like overlay. So it depends on the market situation. Daido has various materials, so we recommend better suitable material for each market.
What's the difference between the aluminum and the copper in that?
So aluminum is a soft material. So it's good for like oil type of engine, but aluminum is soft, so it's less load capability compared to copper-based material. Copper itself is harder than aluminum, so it's good for high load and high performance application.
I think
Okay.
I think we have a slide on this later on, but I'm going to touch on it now. The material selection for engine bearings it's a balance. It's really all based on tribology, and you're looking for decreased friction and decrease in wear, and depending on the overall system, the load on the connecting rod, the load on the crankcase, you really need to have a balance of hardness and softness, and that's where again I think Dido really excels, because we have such a wide range of materials to choose from depending on the application. The softer the material is, typically you'll have better conformability to maintain. Yeah, here we go. Better conformability to kind of maintain the oil film during points of contact, which could be anything from just if you have a weaker crankshaft, or if your application needs to have very small journals, or if for instance, very high speed engines, when we look at like drag racing, when they're upwards of 10,000 RPM or more, you tend to have a lot of crankshaft bending. So you need to have that softness for conformability. But under very high load, it needs to be hard so that it resists fatigue. So it's all about finding the balance of where that engine is happy. So we put a lot of work into analysis and trying to figure out what's going to be what material is going to perform best for each engine, because even the same engine or a similar engine built for the same application, depending on the engine builder, what kind of clearances they like, what kind of oil they run. That all has an effect on the bearing performance and can sometimes change our direction on which material to use.
That's really interesting. That is fascinating and very informative too on the slide. What else did you have that you wanted to show us?
Dusty mentioned about detail about what bearing needs, and this is how bearing material made. So aluminum based alloy. So basically steel and aluminum bond together by cladding method, and copper based alloy material process. So steel and copper bond together by sintering. So this is how bearing material made, and after made material, we make half shell bearing. So half shell bearing, how it makes after bimetal makes blank and bend forming to half shell shape, and if bearing needs to have oil hole, positioning lag, and grooves, will process those features, and after that we have joint face broaching to maintain the crush height position, and after that we have ID finish bore to maintain tighter turns, as Dusty mentioned. The tightest turns wall thickness is like 3 microns. So to control by boring process, we make 3 micron tighter turns parts, and after that, if surface treatment over a feature is necessary, we'll have surface treatment. So this is our bearing manufacturing process, and as Brad mentioned, bearing design itself, it's doesn't much change, but we maintain the small dimensional change, and we have multi-boring technology, which is eliminating crush reef area. Crush reef is parting line reef pocket, but to eliminate crush reef area, it can suppress oil leakage from the bearing. So it can be it can make benefit for fuel economy, and Dido. Oh, sorry. Go ahead, Dusty.
Brad, we kind of touched on that yesterday during our phone call, but multi-boring is really one of the things that I'm very excited to kind of promote, introduce to the aftermarket world, really, especially for drag racing and dirt market guys, because the traditional bearings that you can find for aftermarket performance parts, they do have that conventional crush relief, conventional boring, and eccentricity built into the parts, the same design as they were 50, 60 years ago. Our multi-boring process, really what that means to the engine builder is increased oil pump capacity. And we've had customers that are able to do many different things depending on the application. We've had dirt track guys that can, run just thinner oil, and lower oil viscosity means more power. We've had other customers that have been able to add piston squirters. You can add top end squirters. There's just a lot of things that we are able to do by implementing this multi-boring technology, reducing that oil leakage at the main bearing. And through our bench test studies, we've actually shown that we can actually supply more oil to the rod as well for better rod bearing performance, better rod bearing cooling. It's just a really exciting technology that we're trying to bring into a lot of stock block racing and stuff that these guys just have never known before, because there's just always been basically that same conventional design available.
Yeah. You know what? If I could bring you back in real quick, Mark, and, maybe as much as you can discuss, because obviously a lot of things that happen are very proprietary, especially in a competitive performance industry and all of that. But how working with Dido and engine bearing technology and some of the things that we're talking about might leak over into your world.
Yeah, absolutely. I think Dustin touched on it very well there. At the end of the day, right, this is really the interface. This is how we transfer power from the fuel to the tires to the track. And the way we transfer as much of that power as possible is by minimizing the friction through the interface, but also minimizing the associated parasitic losses that it takes to make that interface work, right, by being able to reduce oil flow. And what we've found working with Dido through their various manufacturing techniques, as well as a wide array of materials, as Tom discussed, right, managing that balance between high fatigue strength in a very hard material, and then also where you need conformability and seizure resistance, maybe in some dirtier environments, has really allowed us to fine tune that interface and look to decrease the oil flow in our engines, or be able to push oil flow to other places, and minimize those frictional losses while still maintaining the durability requirements that we have under let's say conditions in previous years, right? And that's a wide range of operating temperatures. We swing from relatively low temperatures to sometimes extremely high operating oil and coolant temperatures, variations in duty cycle, especially you look track to track, you get some tracks that have a lot more wide open throttle operations, so a lot more load on the bearings than others. And then, like Dustin said, a lot of different oil formulations as well, and opportunities to take advantage of that technology. And then coupled with that, right, we have a lot of our applications, even in the NASCAR world, right? We used to race bearings one race, and now with the seal requirements that we have in the sport, right, we have significantly increased durability requirements for multi-race performance there. And then some of the IMSA and road car applications that I mentioned, right, you start to talk about going from maybe several 100-mile durability or 1,000, 1,500 mile, to starting to having to jump into 4,000, 8,000, 20,000 mile type durability under some pretty demanding conditions. So we feel that our partnership with Dido, and like I say, their advanced manufacturing capability, and also their analytical capability, the ability to evaluate a lot of these options upfront on the computer before we have to get them into the test cell, for durability testing, or even to the track, really allows us, I think, a leg up on the competition, we feel, to continually always be innovating there and trying to stay ahead of the curve.
It's always interesting, the great compromise in performance a lot of times, because while you can make one thing better over here, you might sacrifice on durability over there, or something in another way. And Mark, when you were talking about that, and you know, and correct me if I'm wrong here, but I'm hearing things that, you know, maybe you can get increased power, or at least you're not losing power based on friction, you know, with the oil flow reduction and all of that. Can you describe that a little bit more, and just what a big help that might be?
Yeah, you know, at the end of the day, when we're looking for you know, even very small increases in performance, you know, when you start to look for that last little bit, right, the amount of that you're losing to either friction in the interfaces themselves, like the bearings, or by driving accessories like oil pumps, start to become a bigger piece of the delta that you're looking for at that point, right? So sometimes, you know, if we can find ways to increase airflow or increase combustion efficiency, right, that's a way to increase power. But also, you know, sometimes it's actually easier if you can look to find that through reduced friction and other mechanical losses in the system.
How big of a deal was it to you, and to the sport, let's say, in 2018, when NASCAR did go, started making you guys running sealed engines, you know, multiple races as opposed to one race weekend and all of that? And how did you deal with that, especially as it relates to what Dido does?
That was a very big change for us as well as the entire industry, right? And that came about relatively quickly, that we moved into the realm of multiple race durability, right? So being able to you know, to leverage a partner like Dido to evaluate, you know, like I say, analytically with the EHD and other simulation capabilities, you know, impacts. Where were we really at with oil film thicknesses, oil film pressures, what impact, you know, how does that affect the fatigue life of the bearing, the fatigue life of the overlay, temperature, right? Like being able to lay out those scenarios and say, right, if I now have to double the life or triple the life or whatever it may be, you know, what parameters do I have to start to adjust, either in the bearings or you know, other parameters in the design of the system to make that happen.
Yeah, that's interesting. Dustin and or Tom, you know, maybe if you can elaborate on Dido's end of something like that. You know, now here you've got a big customer that says, hey, our game just changed a bit. You know, let's work together on making this better.
Yeah, I mean, of course, we always try to keep our thumb on the pulse, but we're as a supplier, you know, we're still kind of outside the some of the privy information, and especially according to or relating to the 2018 rule change. You know, I recall that it was like middle of December 2017, whenever NASCAR announced the sealed bottom end rule. And I think the first rule change was two races per engine, and it was a big deal for us. I mean, both in terms of you know, our production and business strategy, as well as you know, the performance of the bearings. So from as the supplier to you know, to that market, it was definitely a point in time where we really had to change gears. And you know, obviously we worked very closely with Roush Yates on making sure that we weren't going to run into any bearing issues, and simultaneously you know, running copious amounts of analyses to try to make sure that, you know, we weren't riding too close to the edge of failure. Because I mean, that balance that we've been talking about a couple of times here, that definitely, you know, the total life of the bearing definitely counts into that. So to double the life of a race bearing can be, you know, detrimental to the program if we don't know what we're looking at. So Tom's group does all the EHD analysis, which is elasto-hydrodynamic analysis, and basically what that does is we're allowed to take the engine block, the crankshaft, and the connecting rod model, run FEA on all of those parts, and actually simulate 720 degrees crankshaft rotation, and look at what the 2D pressure map and or oil fill thickness map. We have just tons and tons of data that we can look at, that gives us insight into what that bearing performance is. So those types of things have really, I think, helped us be successful and you know, producing quality parts for the market.
Yeah, and it's interesting. And again, we're talking about, you know, bearing technology, you know, not really having changed, but obviously with Dido introducing new things in, and some of the things that we even talked about with the multi-boring technology and different thing like that, as far as new products go. And obviously we're here with Mark talking about what Roush Yates does, primarily with NASCAR, but with what Dido is doing in other racing series, from dirt to drag racing to short track and all of that. What can you tell us about that, Dustin?
Yeah, I mean, really, we, you know, as far as the aftermarket racing world, we really started heavily from the top down. Dido's a big supplier to IndyCar as well. We supply to other, you know, professional motorsports, MotoGP, and we've kind of taken that experience from North America and tried to use that experience to design parts for your Saturday night racer, the guys that are on the dirt tracks and out on the drag race, drag strips. And, you know, because we saw this opportunity to leverage Dido technology and to help out NASCAR. We know that there's more opportunity for the weekend racer as well. And, you know, to be able to supply that better technology into the market, I think is something that it's sorely needed. You know, the lead, tin, copper, you know, the SAE material and conventional boring has been around for 50, 60 years, and that's all a lot of these guys have ever known. So we're excited to be able to introduce that new technology and see what our customers have been able to do with it.
Yeah, I think that's a great thing. By the way, if you do have a question, feel free to type it into the chat. We'd love to answer anything that you want to know about as well. Tom, if I could direct it back to you, I know you'd shown us a couple of slides, and I didn't want to miss out on any other opportunity or anything else that you might have wanted to talk about. Is there anything that we didn't cover yet that you also had for us?
As Mark and Dusty mentioned about like EHD and other stuff. So I will share screen again. About one thing is like post test analysis. So Dido always do the post test analysis to measure like bearing wall thickness, eccentricity, free spread, and we also measure like actual direction trace to find out the edge or local wear amount. After like post test analysis, we'll review the bearing design, and if it is necessary to improve bearing design, we will propose like optimum design based on post-test analysis result. And another thing is like CAE analysis. So CAE analysis can predict like bearing condition. So sometimes this tool is very helpful to consider where the like bearing high oil film pressure area. After review the result, we can run with different design parts and propose to the customer for like better design parts. So
That's really interesting. Go ahead.
Oh, yep. So these like technical support is necessary for like performance after an race market, and of course like speed is necessary because race if something happened, we have to fix quickly.
Interesting. If you gentlemen would indulge, you got a couple of questions that just came in from the chat that I want to ask you about. The first one says, for optimizing oil pressure, are the recommendations for oil temperature difference between inlet and outlet flow? I don't know who's the best one for that.
Tom, you want to take that one?
So, like I think bearing temperature like is higher than like inlet temperature. So like optimum bearing shape and maintain oil clearance, and bearing material, different material will help to maintain the oil condition.
Okay. And another question says, are you seeing any issues with bearing damage relating to high oil pressure values?
I would assume that that is referring to gallery oil pressure, but based off of that, I mean, from our experience, you can't have too much gallery oil pressure. That just means that you're pushing more oil through, you know, the mains and the rods for cooling, which cooler rod bearing is always going to be happier. That's one of the biggest issues that we've seen, even you know, with the NASCAR engines, like Mark said. We sometimes see extremely high temperature values in the oil and water. So everything that we can do to keep those cool is extremely important, because that relates to the melting temperature of the bearing material and the life of the bearing. But typically higher gallery oil pressure is just going to promote that flow and cooling.
Okay. And then another follow-up on that. Do you see issues with bearing deformation in areas where bearings have features such as grooves?
No, any sort of bearing deformation is usually due to the housing. You know, really, when you're looking at bearing performance, we're looking at the maximum oil film pressure, which is created by the wedge of oil produced by the rotating shaft. With a groove, a hole, the conventional crush relief towards the parting line, you're not going to build an oil pressure in those areas, because you can't maintain the oil wedge through such a large oil clearance area. So therefore, you're just not going to have any sort of pressure to creating deformation there. Any of that deformation is going to come from the loading on the housing itself.
Mm-hmm. I know we have Mark on here. We've talked a lot about NASCAR and everything, but we've also talked about what Dido does for other racing series and different things that you learn. Dustin, when it comes to, say, technical support and, I'm looking at this application, what is best for me and want to work with you guys at Dido? What's the best way to do that?
So, I guess I should clarify. Are you talking about like kind of the weekend guy, like the?
We have such a wide audience here.
Right.
Maybe the weekend guy has a question, but maybe the engine builder for several weekend guys, or
Right.
looking at something else.
So, and this is one of the things where we have to take our experience with Roush Yates, and even with some of our, OE experience, where, Roush Yates has such, good technology where they can give us cylinder pressure information, where we can use that to run these very, very, sophisticated EHD analysis. A lot of the guys that are building, engines for dirt track don't have that capability. So what we have to do is kind of use our, our experience and try to apply what we know about similar applications to kind of predict what the bearing performance is going to be without that additional information that we just sometimes it's very, very hard to get from the smaller shops. But our experience working with companies like Roush Yates, we get an enormous amount of insight into what a race engine is doing at, say, a specific speed, or similar journal sizes and things like that. So that's where we, I think our experience with Roush Yates has significantly helped us in other areas of racing and performance aftermarket applications, because it's really just irreplaceable experience.
Yeah, and experience goes a long way, especially when you're looking at a supplier for what you're doing. And obviously, you guys have a lot at Dido. Mark, I just want to ask you, one more question, if you don't mind. Again, we're talking about engine bearing technology, and obviously, a lot of what you guys do is very proprietary and very inside the walls of Roush Yates Engines. But just being able to work in every area and to work with a company like Dido, any comments on that?
Yeah, I mean, I think everything really that Dustin and Tom have hit on, from their technical capability to, like we talked quite a bit about the analytical capability, right? At the end of the day, when it comes to running a test cell, there's only so many physical hours in a day to run an actual engine. And when we can simulate, maybe multiple, hundreds of various design scenarios and operating scenarios in a fraction of that time, really allows it to narrow down and be efficient with our test cell time, so we can really focus in on the high percentage modifications that are going to get us where we need to be. And then on the back end, Dido has been a great partner when we do see things that are maybe unexpected in the test cell or from the track, we can get that analyzed very quickly, usually within a day or two, to understand what's going on and get us on a path to addressing it if need be. So I think all the way around, everything that Dido brings to the table is key, especially in the NASCAR world, right? Every weekend we go racing, and there's really no downtime in between until the off season. So if we're looking to make improvements or need to make a change to address an issue, we got to be able to do it fast.
Well, Mark, we do wish you guys the best of luck this weekend. Every time we talk about Daytona, we do talk about Roush Yates power and just how strong it is. So good luck and thank you for joining us. And
Thank you.
Tom,
Appreciate that.
yeah, no problem. Yeah. Hey, look, hopefully Doug Yates is giving away some valve covers on social media later on next week after a couple of victories. But
There we go.
Tom and Dustin, really appreciate you guys as well. And thank you for such an informative webinar here. And it's really cool what you guys are doing with Dido and with engine bearing technology.
Thank you guys. We're very excited to finally get on here, and definitely appreciate the opportunity.
Thank you very much. Thank you. So this webinar has been recorded. It will be posted later on the EPARTRADE platform. As we mentioned, this is episode 350. So if you want to watch the 349 previous episode, please go on epartrade.com. They're all available for you. In the meantime, we push Daido medals back on the homepage of the EPARTRADE platform. Again, we build this platform for you, the industry. Please take advantage of it. Thank you very much. We will be back next week live with Shop Monkey on Wednesday at 9 Pacific. Thank you very much. Bye-bye.
EPARTRADE is a digital platform that we've created basically to make life easier in the business community of auto racing.
EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With Shop Monkey, we've been able to grow the shop by 20% in gross sales since implementing it in the shop. Everything that we were doing before has been sped up with Shop Monkey. All of our parts ordering, all of our approvals, all of our mechanics knowing what to do next. And I've had friends that are in the trade that own shops ask about Shop Monkey, and I highly recommend it just because of easy use. There's nothing like it with that kind of platform.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series.
For over a decade, Fifth Third Bank has been a staunch supporter of our industry and a great partner for many companies in the motorsports field.
Our business has been growing extremely fast, and really we could not be where we are today without Fifth Third. They provided amazing strategic advice, the capital we need to support our phases of growth.
They are true partners for me now, and what they do with their involvement in motorsports is untouched in this community.
Where can we take your business? Fifth Third Bank.
Scott Lewis and Associates, the sales, marketing, and branding specialist for the automotive performance industry since 1988. We get our manufacturers on track by opening an extensive distribution network, providing product training to sales staff, creating fully integrated sales and marketing strategies, building successful industry partnerships, attending trade shows, events, and races, offering first-class support to customers. SLAI delivers solutions that win you sales. To get in touch with an SLAI representative, call 516-378-6100. Go to scottlewisinc.com or email info@scottlewisinc.com.